Hello, in this video, I am going to go through the unit circle. I really love the unit circle in math because I feel like it's one of the most powerful tools to be able to do things in your head rather than needing a calculator. So it really frees up your ability to do a lot of trigonometry. I do know some people are rolling their eyes at me because they have a calculator and they feel it's kind of silly, but I think it's really helpful to understand. And it's also something that I really struggled with. I remember in my trig class, I had to take a quiz and pass it on the unit circle before I could move forward. And Miss Gerster probably saw me more than any other student coming in to repeat the quiz. So I try to break it down so that it's a little bit easier for other people to learn. So the unit circle, I always start with just drawing a circle. I also am not the most practiced at drawing, so it's a little bit of a messy circle. And then I draw a line going across horizontally, a line going across vertically. And so we can label our quadrants 1, 2, 3, and 4. They make a C. And we start at this end with 0 or 2 pi, or in degrees, this could be 0 degrees or 360 degrees. So just a reminder on the side, we know that pi radians equals 180 degrees. Pi rads equals 180 degrees. I usually think about my unit circle in radians, but I know some teachers like degrees, so I'll try and make sure to point out both. And so also we have a point here. So at 0, 2 pi, our x value is going to be 1, and our y value is 0. And on the unit circle, x corresponds with cosine, y corresponds with sine. And so then here we have pi over 2, which is also 90 degrees. And now notice our x is 0 and our y is 1. So we can write this 0, 1. Come all the way over to pi, which is a straight line, 180 degrees. You can also see the connection between pi and 180 degrees at this point. Now our x is -1 and our y is again 0. Last but not least, on these major points, we have 3 pi over 2, also known as 270 degrees. And this is point 0, -1. All right, now we're going to get into more. So here, I'm going to draw in my lines for pi over 6. And so the next point is pi over 6 radians. This is the same thing as 30 degrees. And this point is the square root of 3 over 2, 1/2. Then, if we go all the way over to the quadrant 2, we have 5 pi. Oh, 1 second, that's a lie. Oh no, that's correct. We have 5 pi over 6 radians, and this is 150 degrees. And notice always that the bigger gaps, so going between the black and the purple lines, these are equivalent to 30 degrees or pi over 6 radians. All right. And at 150 degrees, our point is negative square root of 3 over 2, 1/2. All right, jumping down, we have 7 pi over 6. Again, noticing the pattern, pi would be 6 pi over 6, so we're just jumping up by a pi over 6. Whereas you'll notice on the long lines, we change by 4 pi over 6, which we'll see again here. Actually, this point's going to be 11 pi over 6. This is 210 degrees. And this last one here, 11 pi over 6, think about this. We just subtract 30 degrees from 360. This will be 330 degrees. And the points, so our quadrant 3, this is the double negative quadrant. which is negative root 3 over 2, comma, negative 1/2. And finally, in quadrant 4, we have a positive x again, but a negative y. All right, so that is it for the pi over 6 radian family. Next, we'll go into the pi over 4. Ooh, I want to change colors here. So this here, pi over 4. Now these smaller jumps, which I know it doesn't look a lot smaller, but this is smaller, are by 15 degrees, which is also pi over 12. And so when we're at pi over 4, this is 45 degrees. And the point here is square root of 2 over 2, comma, square root of 2 over 2. Please note, the square root of 2 over 2 can also be written as 1 over the square root of 2. And that's how it's done in a lot of calculus classes. In pre-calc and trig, though, we often rationalize the denominator, which is why it's written here. If you're struggling to see the connection between these two, just go ahead, multiply numerator and denominator by the square root of 2. This gives us square root of 2 over 2. So we see the connection. All right, so jumping over into quadrant 3, or quadrant 2 rather, this is 3 pi over 4. Subtract 15 from 150. That gives us 135 degrees. And you might be able to guess it by now. Our x is negative, y is positive. So this will be our point. All right. And with the pi over 4s, we're always changing by 2 pi over 4 because they're evenly spaced. So the next point is going to be 5 pi over 4. And our very last one will be 7 pi over 4. 5 pi over 4, this is 225 degrees. And this is our double negative point, root 2 over 2, comma, root 2 over 2. And 7 pi over 4 is 315 degrees. Y is negative, x is positive, root 2 over 2, comma, negative root 2 over 2. All right, we are getting so close. So when you have your pi over 3 points, the points are exactly the same as pi over 6. We just flip the x and the y. So pi over 3, this is equivalent to 60 degrees. You can think about it either as a jump by 15 from here or back 30 from here. And this is now going to be 1/2, comma, root 3 over 2. All right, with pi over 3, if we have our closer pi over 3 points, we just increase by 1 pi over 3. So here is 2 pi over 3. This is the same thing as 90 plus 30, so 120 degrees. Notice it also fits the pattern. 120 plus 15 gets us to our 135. And so we can write this point as negative 1/2, x is negative, comma, root 3 over 2. All right, now we're jumping all the way down. So now it's going to be 4 pi over 3. That's right here, 4 pi over 3. 4 pi over 3 can also be known as 240 degrees. And it's going to be the same point, but now this is our double negative quadrant. Negative 1/2, comma, negative root 3 over 2. All right, and last but not least, we have 5 pi over 3. This is 270 plus 30, 300 degrees. Fits right in the pattern. By adding 15, we get to our 315. And this is going to be a positive x, but a negative y. All right, and we have essentially completed the unit circle. 2 notes that I want to make because I think it's kind of worthwhile. Let me see if I can move my screen. Just a second. Kind of the connection between the unit circle and special right triangles. And so that connection is our 2 of our special right triangles, the main ones I think about, are 45, 45, 90. And we know that this is x, x, and x times the square root of 2. And so this kind of makes sense because we can think of root 2 over 2 as our x's. And then x times the square root of 2, this is root 2 over 2 times root 2 over, or times root 2. Root 2 times root 2 gives us 2 over 2 equals 1. And the radius of our unit circle is 1. So there's one of our special right triangles. And then our 30, 60, 90, we know is x, 2x, x times the square root of 3. And so if we think about x being 1/2, 2x would be 1, and x times the square root of 3 is the square root of 3 over 2. And this is the points that we see at our 30 and 60 degrees. The very last thing I will note is that I struggled to see these patterns initially. That's why I color code it to make it a little bit more clear. But if you're still struggling with where we do a pi over 6 versus a pi over 4, you can convert these to pi over 12s. So we start with 2 pi over 12, 3 pi over 12, 4 pi over 12, 6 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 12 pi over 12. You could probably follow the pattern for the rest of the circle. And so that is always an option if just converting to pi over 12 makes more sense to you, and then simplifying those fractions. All right, happy studying the unit circle.